This conference will now be recorded.
So this is the agenda which I'm proposing to discuss today. I'm just going to go and give you a quick HS2 project overview, just to understand a little bit of what we are doing in HS2. Then I will go into the high-speed track system design challenges, and that will conclude with some question at the end, hopefully. Right. So HS2 project overview. So this is HS2 has got the aim to bring Britain closer together. So it's in total will be around 345 miles of brand new high-speed railway, which will connect Birmingham, Manchester, Leeds, and London. So HS2 trains will be designed in order to run on existing network as well, serving towns and cities in the northwest, northeast, and also Scotland. So HS2 will connect 30 million people and 8 of our largest city with 25 stations from Scotland and southeast. So how is HS2 structured and how we are going to build it, basically? We have phase 1, which is from London Euston to Birmingham. So Birmingham, which is the section which is currently undergoing civil works already, and we will go there in a minute. Then is the phase 2A, which will extend the line from Birmingham to Crewe, and phase 2B, which will complete the lines to Manchester and to Leeds on the east leg. So the works are planned to be completed by 2040. So what's the HS2 mission? And you know, we are trying to bring more capacity in terms of having more trains running and reducing the carbon. What means that? So bringing the traffic from our roads to the railway, but and also making a better connectivity between the south and the north. A little bit about the work of progress. I said already, we have civil contractors already with boots on the ground doing works on. So we have like a joint venture like BBV, which is Balfour Beatty and Vinci. Then we have AKB doing works around Buckinghamshire, and we have a line which is doing works on outskirts of London. So things like Chiltern Tunnel and the longest Colney Viaduct, which will be the longest viaduct in UK. And we have SCS Railway, which is the one who delivering Euston and Oldham Common. Just a couple of visual now to show what is the proposed station will looks like. So this is the Birmingham Curzon Street Station. This is how the architects on HS2 make a visual. This is how it's going to look like, and this is the Euston Station. How it is going to look like. What's the operational challenge? So basically, it's we will have, so this operational speed is 360 kilometers per hour. That's and also the plan is to have 18 trains per hour. So that sounds like a high-speed metro. So it's really challenging to have a railway which is going to be reliable and available and, you know, maintainable and so on and so forth. So, and also, as I mentioned before, you know, it's having the trains capable not only to run on the HS2 infrastructure, but also to run onto the existing infrastructure. That's going to be real challenge as well. So that's a little bit about the project itself. So I'm going to discuss a little bit about the challenges which us as in the truck department we are facing, and how we arrive to some of the conclusion and some of the option which we considered before. So obviously, you know, we considered at the beginning of the project what's going to be ballast versus slab track, and you know, some of the main consideration when you look at the truck system is you know, are listed here. So they are cost, service life expectancy, maintenance, passenger comfort, and safety. So safety, it's I say paramount, and because of the speed, you know, it's the accuracy you have in your installation. It's a paramount. So we did explore all of this, and somebody will tell me, oh, yeah, well, having obviously slab track, it's more obviously more expensive than slab, which is fair enough. But I think lately, you know, and slab track is not something which is let's say very popular in Britain, I should say. So we had lots of challenges from different departments of DFT to prove why a slab track is going to be better than slab. So as I said, you know, it's in addition to, you know, the systems. Yeah, I put safety. Sorry, I put safety at the end, and somebody will ask me why safety. It's because after, you know, after 320 kilometers per hour, which is the highest speed for a high-speed line, let's say like in France, for example, the risk of ballast flying, it's you know, almost impossible to contain. So having a ballast track for 360 is something which is doesn't exist, and something which is not proven anywhere. So that's the reason I put the safety also in this slide. Okay, so we choose the slab track, and we already have the pour, which is a little bit in an unusual contract for them. I don't know if you know, but pour, it's a truck slab contractor, and they are experienced on high-speed truck, on metro, so they are an Austrian company. But in our contract, they will deliver only the precast slab, so the top slab of so you know, they have to design and manufacture and supply those precast slab, and this is going to happen in UK, and they will have a factory which is in Somerset, close to a quarry, and you know, to tackle all the environmental issue and carbon reduction as well. So yeah, so Pour is working closely with us for a year now, and trying to develop you know, the truck system design per se, having the challenge to you know, to have a different type of slab, as you can imagine, you know, because in some area, especially some residential area, we will have the need to have a different slab to deal with noise and vibration. I'm calling it a resilient slab, and some of the area we will have some enhanced resilient, I should say, which was quite challenging for us, you know, like introducing for those which you are you know, a little bit more of a slab, you know, floating slab track. So it might be the solution in some area where, let's say, we have a residential building on top of tunnels, or even we have care homes and so on and so forth. So looking at the Trackwork packages, so Trackwork are part of the railway system. So how we split it is on track on the north, which is part of the you know, Birmingham and down. Then is central, which is central of the, and urban, which is London basically, and the outskirts of London. And then we have the track package for phase 2A, but phase 2A is not so advanced. So it's the civil work didn't start yet. So this three track, north and central and urban, is the one which are now will be, hopefully we will have a contractor by the end of this year in December. Other packages, as I mentioned already before, the precast slab track. So this is a PRE contract, which are working with us for more than a year now, a little bit more than a year. And then we will have a contract for rail, which is CN60 rail. We are negotiating as well. And another contract would be the switch and crossing contract. So that's interesting, because we are having lots of challenges with choosing the geometry, and because of the civil footprint, as you can imagine. So this is the contract. A little bit about contract quantities now. You know, as I mentioned, this is the phase one contracts which are now live. So we have the overroute, as I said, which is on phase one. You can have a look here on the amount of work which we are need to deliver only in phase of 80 kilometers of embankment, and also cutting, I guess, 60 kilometers, 15 kilometers of viaducts, and so on and so forth. The tunnels, only the total tunnels will be 39.4 kilometers. Only Chiltern is 60, and then this is standard bore tunnel, and then we have the cut and cover tunnels, so which are a little bit shorter, but still 13.4 kilometers. So, and then switch and crossing, we have 170 units for phase one and phase 2A, and the rail expansion devices, we have 75 units along the route on phase one and phase 2A as well. So the precast approach of the slab track. So how is the track system looks like? You can see in this picture. So we have, as I mentioned to you before, we have the precast, which is going to be delivered by the PRE, and underneath we have you know, the HBL and which are being built by the track contractor. Yeah. So and the concrete bonding layer between those layers as well. So this is how a cross section will look like for most of the areas. But as I mentioned before, this is applicable only for those areas where we don't need any what I call the resilient slab track or you know, enhanced resilience slab track. And this is the sketch of the slabs, how they are going to be. So the lengths of those are 5.16 meters and 2.4 meters width. So this is the standard slab which Core are going to manufacture and deliver to site to our track contractor. One more thing which I wanted to mention, because of course under the SNC we will have different type of slab track, but that's not in the scope of PRE because of depends on as you can imagine, we have what I call high-speed SNCs with swing noses, and only for that area we mandating as HS2 as to be precast slab track, but you know, the track contractor will choose the precast on his own, because, as I said, it's not included in the PRE scope. And another, another SNC, what I'm calling conventional SNC for lower speeds, might be, cast in situ or other optional or precast. So we are not mandating those, because that's something with the truck contractor we are expecting to bring in and price for. A little bit of the, so I mentioned briefly, this is how it's going to look like. All the picture I have to mention are courtesy of POR, so they allow me to use them, so it's no problem. This is, as I said, the down picture here with the precast is from another job. This job is from Doha, so they have a facility similar with what we are going to build in what they are going to build in Somerset, as I said, and they are making provision, and they will start to do that later on in the program. Construction method, again, this picture is subject. So choosing the slab track, so we need to make sure we have a construction method in place which will allow us to less or very little shimming once the track is installed, and have leave the shimming for the maintenance rather than doing the construction. So accuracy and survey installation and construction, it's a very key. But once it's installed, a slab track need to stay, well, to stay for at least 60 years. And very little maintenance, and if apart from fastening and rail checking and so on. So the slabs are designed and built to last for that long. So when you put that in equation, so the cost which you calculate for a ballast and slab, it's nearly, you can say you are making a square. This is how a complete system, PRE system, looks like. This is from another project. Obviously not in UK. They didn't do any high speed in UK. So this is how final work will look. Going back to some of the challenges again, track design challenges. So we have track alignment and track quality, very important, as speed and passenger comfort and everything else is key. And then Earthworks Interaction, we have the challenge, with the settlements, and when you have a slab track, it's almost you have to have the settlements free. Let's say earthworks. Of course, that's not possible everywhere, but as long as the settlements are uniform and long, it's not an issue if it's not differential settlements, I should say. That's something which is not acceptable, especially for a high-speed railway. Other challenges, as I mentioned, sound, noise, and vibration, especially ground-borne noise, and I will talk about it later on. And also integration with structure, bridges especially, and also tunnel, because you have a interface with those as well. Track alignment and track quality, obviously, the tolerances when it's when it's about high speed, it's very important to have almost perfect alignment, I should say, and installation and monitoring of those. It's very important. And again, the achieving an alignment which is capable to run 360 kilometers per hour train in terms of parameters like rate of change of current and efficiency and so on are key elements, and due to the constraints of land acquisition, sometimes we need to, as you can imagine, we don't have a long straight alignment from London to to Birmingham and so on. So it's lots of curve, which high count and so on and so forth. So yeah, in terms of survey, I mentioned that because the survey HS2 is using what is called snake grid. I think those Nicoara has got something similar. A snake is so the snake grid. It's a very powerful tool because of the accuracy of the precise integration of the design. So you can imagine, I give you, so for example, if you use the normal ordnance survey, you will have a 60-meter difference between the snake grid and the ordnance survey. So that's quite a lot, even. So having something which is like snake grid, which is like measuring, a flat surface rather than measuring our. So it was very important for us to have this implemented. And yeah, the survey team is part of my team, of the track team. So I'm working closely with, as you can imagine, with other railway systems to implement the survey requirements as well. Earthwork interaction, as I mentioned before, again, this is very well. When you have a slab track installation, it's so critical when you are going to start to install the slab, and what kind of the settlements you are going to have, or heights you are going to have there, and so on and so forth. Because it's once you install the track, if your settlements are under, if you have a ballast track, well, we can go there and tamp, and we may fix the alignment. That's quite not the same with the slab track, because we need to make sure to the handover, when the civils handover, it's so the truck it's ready to be laid, to install the and also to continuously monitor to see if the empirical mathematics are proven, and actually, we don't face any issue with the truck installation, and don't have any problem. On the earthwork interaction, the Kiva settlement, as I said, they are very, very critical. Normally, your earthworks, it has to be almost settlement free. But we went to, and in our standards now we allow for a 30 millimeters maximum 30 over the 60 years period of and that's, as I said to you, those settlements should happen, continuously on a long stretch of rail, not having, differential settlement and so on and so forth. So we went you know, because having, let's say, and earthworks which are settlement free, that will include a lot of piling and extra cost, as you can imagine. So we need to go above and beyond in order to make sure you know what we are allowing in terms of settlements. It's manageable in terms of operational and maintenance and so on and so forth. So another issue is the heave, you know, those because sometimes because of the nature of the earth or there you can have heaves, not settlements. So that of course it's another big issue because that can break, and how you manage those can have bumps and you know, problem with your fastening and so on and so forth. Sound, noise, and vibration. So that's really actually very critical, and I was involved very heavily in lots of models which we worked together with our contractor, POR, in order to develop a solution, you know, for groundborne noise. So as I said, you know, this is you have the airborne noise, which is you know, I mean, you know, it's not much you can do, but when it's about noise in the tunnel, first thing it's you know, the people are coming, what truck can do. So the truck can do. Luckily, we could explore with PORE, and we find a solution which is something which is on, you know, you may know from metro or you know, or tram solution, which is called floating. So it's a sort of floating slab which having some spring underneath of those, and allow basically the slab to go together with the train, and that's will deal with the groundborne noise in those areas. So lots of challenging, and you know, just to find actually we have a solution, because you know, this is we have the requirements are very high in terms of groundborne noise and vibration, especially in the area where we have residential area, or as I said, you know, in some area we have you know, like nursing home or so on and so forth. Another issue, oh, sorry about that. Another issue is integration with structure. So this is something which we are once you have slab track and on top of the bridge, one of the major issue is to how do you integrate that slab with the bridge, and our civil partners come with lots of skew bridges, and also, you know, when which are really challenging. But you know, having PORE and their designer VC on board, we managed to find solution for each challenging bridge, which is proved with very successful work. So but again, you know, the limits of the you know, the viaducts and how the forces are you know, are to dissipate those, where to install the rail expansion devices if it's necessary, and so on and so forth. Because having a continuum long structure, as you know, somehow you need to allow for movement, and the only way is to install rail expansion devices. And that's I think that's all from me. To be honest, I hope you find this interesting. And if you have any question, I will be more than happy to respond.
Right, thank you very much, George. Right, we've got the first question come in from Paul Ebbert. And he says, what are the tolerances for the sub-slab top and line to support support the poor units?
The tolerance in terms of settlements.
Yeah, in terms of the construction tolerances, I imagine he
Construction.
means.
So yeah, very good question. Yeah, I forget to. So basically, for the main line, we have top 650 millimeters. It's from top of rail to the frost protection layer, I should say. So, but it is about like always. We allow sometimes because of the drainage interfaces or in the station, we have a solution for 500 as a minimum, but that's only approved, because we have in places like Old of Common, we have area which are they have voids and so on, and they have a big problem with the drainage and so on, and so we have to come down from 700 to 500 in those areas. So and that's to include the precast and the HBL and CBL layers. I hope that answers your question.
Thank you. Well, I'm sure Paul will come back if that doesn't answer his question. Okay, thank you. A question from me. Why did they choose 360 kilometers per hour as the speed? Because that really is, from my experience of high speed railways, which is not large, I mean, the energy consumption seems to be very high at those kinds of speeds. And as you say, you've got all the issues of picking up dust or ballast or things like that. So
yeah, so basically the speed,
why was
the operational speed came, so my track standards, the design speed is 400 kilometers per hour. So that's design speed. So operational speed came after, we have our operational people, they run, a program and simulate in order to see what's the speed in order to allow it. So they came up we need that number of trains and what speed we need in order to have 18 trains per hour, for example. So this is how. So I think the speed, the design speed from a track point of view, it's a very high speed. As I said, 400 kilometers per hour. It's to have the German one and the French one is 320, or then China they have 350. Yeah, and I think it's an obvious. It's a very fair question. Why do UK choose 360? So 360 came after this operational modeling and to support what was the view in terms of having that number of trains.
Right. Okay. Is there any problems envisaged with the overhead line at that speed?
The overhead line, that's a good question because of I think the catenary which will be selected at the end. We don't have a solution. Should be comply with those speeds as well. And we have now the support which we have is from my colleague Pascal, which is the head of OCS, we are calling it, so overhead catenary system, not overhead line, is having the French SNCF is doing the is helping with the the basic design and everything else of the catenary system. So hopefully they said they have solution for 360 kilometers per hour. Yeah.
Right, thank you very much. Right, Ed Green asks, what is the projected future maintenance burden of this slab system? What kinds of on-track machines do you foresee you will need?
Very good question. So basically, the life expectancy, as I said, for a slab is 60 years. Yeah. So now you can imagine it might be some issue with the cracks or something in some area, or some area where some unpredicted let's say, hives or settlement will occur during the, during the operation, something which it doesn't, didn't, result. So so in terms of maintenance, they will be available, how we are calling spare slabs, if that's necessary. But also the maintenance manual will have, let's say, if it's only necessary to repair cracks or something like that, we'll have that part of the predictive or preventive maintenance will be, included in that one, how to, to do small repairs, let's say, if it is not necessary to, to change the entire, slab unit. Yeah. So yeah, I think having that say, it might be the case, yeah, when something unpredictable will happen, but it's covered in the let's say in the maintenance manuals. So maybe either changing the slab or repairing the cracks or so on.
So Ravi Koala says, what is the design of the track drainage system? There is an access at the center of the track in the photos. Is that for drainage access or for maintenance of floating slabs?
This is where it's going to be the manhole, yeah, and then the connection to those manholes. So we'll be running track drainages, let's say, and then connected to those. You see in the picture very well, yeah. This is where the drainage will be connected, and it will be accessible, to see and to visualize and so on, yeah.
Okay. Andrew Wilson says, does the track curvature need to be considered in the slab design for adjustment of fastenings?
Yes, very good question. So depends on so normally you have the fastening, between 10 and 15 kilonewton per meter. That's the load, let's say, which you consider. But that depends on the curvature, or we have and also radius and also cant. We have a prescribed, tow loads in order to cope with the extra stress because of the so depends on that. We are prescribing what is going to be the tow load in the fastening. The same on the bridges, which is the movable. We are using some special fastening in some area where we have slabs, and we have structural expansion joists in those areas, because they are going to be more, how should I say, under pressure from the rail. It's going to be a sort of special base plates and special fastening to cope with those stresses.
Right. So Dave Merritt asks, did you break the slabs over the bridges? What was the approach? And it ties in, I think, with another question we've had from Sankadev. Is the decision to have both low tow load fastenings as well as rail expansion joints, or is it a trade-off under discussion?
Very good question. Yeah. So obviously on the structure, the problem is, with the structure, our structural college. I don't like problems. Normally I call challenges. Once you have a long structure, yeah, and you don't have a structural expansion joist in that, obviously you need to put a rail expansion device, we are calling, or rail expansion joint, like netto rail we are calling. So normally, before any truck engineer will, including me, I don't like rail expansion devices. They are highly risky, and it's unless it's really necessary, we shouldn't install them. But it is the but. It's sometimes for the price and everything else, you have to make a decision, and it's needed. And I can tell you, I told you about the long viaduct. I have on a curve which is 15,000 meter radius curve, and I have high cant, and I will have rail expansion devices there. We tried before that, we tried to, you know, I don't know if you heard about ZLR fastening, zero load. Well, it's almost zero, it's not zero, it doesn't exist, but it's called zero load resistant fastening. So that's somehow, if you have that, can compensate the need of rail expansion devices. But in this case, it didn't work because of the length of the viaducts and everything else. That solution. This was my first challenge when I joined this. When I joined HS2 almost 2 years ago, I said, "Why so many? Why we are not using?" But the problem is, you know, when the structural guys, they are coming with the track structure interaction. You know, they put that in the model and they demonstrate. Look, it doesn't work, whatever, because you you are not allowed to put the entire length of it. You are restricted how long you can put the ZLR. So yeah, but it's a very good question. Yeah, it's because these ZLR are very good, and I did myself in a previous job, and I managed with ZLR to avoid rail expansion devices on a very long viaduct.
I agree with you. They are a liability, aren't they? And I think it's a challenge I've made myself too about why do we need them. And I did manage when working with the structures engineers, we looked at what we could do, and actually we got rid of them in the end. So, right. IN Ismail says, "Thank you very much for this interesting and comprehensive presentation. If you do not mind, please may you share some more information on how the precast units interact with the substructure and earthworks below. Is there a standard earthworks design, as is the slab, or does this vary depending on local conditions?"
Yeah, no, it is. Yeah, so it is vary, and standard earthwork design is in my colleague, the geotechnical head of geotechnical. So but he's working very closely with us, and yes, it is depends on, you know, as you can imagine, if you have an embankment, if it's high embankment, it's one design. If it's in a cutting, it's different design on the earthwork. And you know, normally a slab track for a high speed, you have to you have to allow for 2.5 meters below your last layer, let's say below CBL, let's say, to have a strong earthworks. But if you go by that, you know, our rail will cost a fortune. So that's the theory. So we are going, as I said, working very closely to see, depends on, and working on which type of an embankment to see, you know, how much we can, you know, we can allow. And as I said, when I arrived here, it was 15 millimeters only, based on the German experience. And now we relaxed to 30 millimeters of settlements, of long settlements. So as you can see, we are making a lot of effort in order to not only to make this happen, but also because we are spending public money, and the money need to be very well spent and demonstrate what we are, you know, achieving.
Okay, thank you. Right, James Hepburn said, "Is the slab track form exactly the same in the tunnels?"
Very similar, yeah. As I said, very similar. In most of the tunnels, if we don't have a noise and vibration issue, will be exactly the same like in on mainline, let's say, on bank. So, but if you know, some of the tunnels, as I mentioned already, will be different forms, because we have the ground bore noise issues, and therefore there will be a, you know, like an enhanced resilient or at least a resilient slab track form.
Yeah, the floating slab track. Yeah.
Yeah.
Okay, right. Ravi Korala says, "Yeah, are there any tight radii locations on HS2? And if so, are there any guardrails at these locations?"
I think I didn't hear that question, Andy. Your mic is breaking. It's the last one. This one. tight radial location in HS2. No,
Sorry,
well,
Ravi Koala says, are there any tight radius locations on HS2?
yeah, no,
Yeah, and if so,
well,
are there any
the only tight radius which we are having.
guardrails?
Yeah, no, we don't have that tight to go to,
Yeah.
you know, because it's high speed. We have some tight radius around on phase 2B around Piccadilly. It's 1,000 meter radius, but of course the speed is accordingly because you know, Manchester Piccadilly will be a terminal station there, so the speed is like 50, 60 kilometers per hour, so like 30 miles per hour speed. So and they have 1,000 meter radius, so it's not tight for that speed, I should say.
Okay. Paul Ebbett says, are noise screens at the CES needed the whole length of the slab track?
No, they are not. They are area though where we identified we need some what I am calling noise barriers in some of the area because of the speeds, obviously, and stuff like that, but not everywhere.
Okay. Well, another question from me. I gather you've got a design life of 60 years for your slab track.
Correct.
Do you think you will achieve that? UK experience with slab track, and admittedly we've installed slab track in a lot of places on existing formation, or in places where the formation's poor, it's been put in as a special treatment. But a lot of it hasn't lasted 60 years. I wonder what your feelings are on how well it's going to do on HS2.
Yeah, very interesting question, Andy. To be honest, based on, as I said, based on you know, poor experience, and they did a lot of high speed in Austria and Germany. Even now, you know, before, and they are still doing. Now, you know, most of the slabs are doing well, and there's no problems. You know, the only problem will appear where in those areas where something you know, unexpected is happening. You know, it's something which is we didn't predict, and we didn't, you know, we you know, it's like it's not like it was an error, but it was something which is not really you know, allowed for. So I mean, you know, the problem is, you know, as I said, you know, in UK we don't have that much slab track. Lately, you know, especially precast slab. I think, I don't know if you are aware, but Transport for London installed the precast port slab on the Barking Riverside viaduct. It's not, of course, the speed there, it's 60 miles per hour, I think, or 80 kilometers per hour. But it's a similar system with ours. And I went on site to see, you know, the quality of the works, especially in the installation, because, you know, it's so it was a pleasure to see, you know, the very good quality. And I also been with my survey team to witness the survey done, you know, for the AFC survey, I should say, and that was bang on and very, very accurate, the installation and so on and so forth. So it is looking, let's say, positive. To answer a question, if they will last 60 years, I hope so. You know, I don't think I'm going to be here to witness 60 years. I'm quite old myself. Hopefully I will retire in less than 10 years, hopefully. But yeah, I'm quite positive, and I was very happy you know, to bring my experience, because as I said, I did a little bit of work before on. I don't have a huge experience on slab. You know, I have a lots of experience on ballast mainly, and slab on metro and trams, but not on high speed. But you know, I trust you know, our contractors, and I know they did well before, so hopefully that's going to happen here also. So.
Okay, thank you, George. Right, have we got any more questions? I think we've gone through all the questions we've got now. So unless there's any other questions, I would like to call upon Andrew Wilson to propose a vote of thanks.
Thank you, Andy, and thank you, George, for stepping up and giving us an absolutely spellbinding description of the challenges that you've got in the Trackform for HS2 and some of the peripheral questions that you've been able to answer as well. We've known each other for, I don't know, must be upwards of 15 years now, and when I found out that you were in HS2 on track, I was delighted and thought, really, there must be something to get out of a presentation from yourself, and I'm sure that we've all had that this evening. High-speed track makes us all think. There's lots of questions that we could ask, and we could probably keep talking for hours about what goes on. Perhaps we better just remember ourselves that the first thing that a permanent way engineer realizes is that the permanent way is never permanent. But this is just about as permanent as you can get it. And the price of failure, if you're trying to make something for 60 years that ain't gonna fail, is indescribable. So that really, at 18 trains an hour at 360 kilometers an hour, there's no opportunity for single line, asking questions about single line working, or if you need to change a rail between trains or something like that. Indeed, a question I'd like to ask, and I'll just leave it to the audience to think about, is if you do have to change a worn rail, how long is the run out from the worn rail? And so how many different specifications of worn rail has the section supervisor got to keep in his undercover in his shed for just such an eventuality? So, George, with that, I'll sign off and say thank you very much indeed for really enlightening us about HS2. We'd love to have another presentation when things are getting a bit more construction orientated. We'd love to go and have a look at the casting of the track slabs in Somerset. All these things are things that I'll try and arrange in the fullness of time. But I'd like to ask everybody if they can just open their mics and join with me in thanking George in the usual manner. Thank you, George.
We just had one more question come in, George, just before we finish. Nathan Bunce has asked, does HS2 have a defined process for stressing of the swing nose crossing areas?
Good question. Yes, well, we have this is all the, you know, the track will be a CWR, yeah, continuous welded railway, as you can imagine, and the process of stressing, you know, the swing nose, it's going to be you know, one of the challenges, and how because of the movable part of it and positioning of the, you know, having the swing nose, as you can imagine, you know, they have additional point operating equipment also to grab that and introducing more stressing. And to be honest, you know, I cannot say myself. So we went and we obviously have learned from the Germans' experience on that. So we are going to apply the same what Deutsche Bahn is doing in Germany.
Okay, thank you for that. Right, okay, so with that, our next meeting of the section will be on the 11th of April, and this will be a face-to-face, either at the Clayton Hotel in Cardiff or in Network Rail's offices. We've still got to do that, and that will be Rob Knapman coming back to do his talk on first aid, and a chance to actually, for us all to actually to learn from that. Yeah, and then on 9th of May, our final meeting will be the Excalibur Timber Sleeper Bolt, which is a new product on the market, and should be an interesting one for all of us. So, okay.
Okay, thank you very much for having me.
Pleasure.
Okay, thank you, George.
Thank you, George.
Bye.
I'm going to hang on for a few minutes if anybody wants to chat. So.
Well, yeah. Hi, George. Hi, George.
He's gone.
Where's gone?